Okay, we are live. Hello, hello, and welcome to the second DaScript Q&A live stream. Today, the main host will be Boris Batkin. I think he will introduce himself better than I can do. We will cover most of your questions from the form that you filled, and after that, I think we will also talk about like more advanced DaScript stuff. So yeah, feel free to ask any questions, and yeah, let's begin, shall we?
All right. Without further ado, first let me introduce myself. Name is Boris Batkin. I write code. I wrote most of DaScript, and I'll be the person who will be accepting most of your PRs. So let's start with that. DaScript is first and foremost an open source project. In the true sense of open source, meaning the source is open for both reading and writing. We love PRs, we accept PRs, and we're heavily overloaded. That means if you have feature requests which you can fulfill yourself, or you think something is missing, not beautiful enough, not properly documented, doesn't make sense, could be better, could be improved, please do not hesitate. Make a pull request, make it happen. I'll gladly work with you. I have a strong policy of mostly accepting most of PRs or working with you to make sure it compiles on every platform. But outside of that, if it's straight up improvement, it will be merged. DaScript's huge. DaScript is ginormous. It has a lot of modules. Unfortunately, it does not have enough modules. We do need your help. And on that note, let's talk a little bit about documentation, because quite a few questions out there are, what's documented, where it's documented, how it's documented. First and foremost, there is a website, starts with dascript.org, and at the very bottom there is a link to the documentation. Half of it is handwritten, half of it is automatically documented. I'm currently in the process of implementing something similar to Doxygen. That thing will allow inline documentation, and that will allow me to greatly improve documentation of modules, particularly the ones written on DaScript itself. Currently, the system is slightly cumbersome. Standard library documentation is automatically generated, and for the most part, you're going to see it to be documented soon. I don't know how long till the soon portion. If you see some documentation missing and you think you can fulfill that gap, I'd highly appreciate it. Right now, it looks like months and months of straight up documenting for me alone. I cannot do it alone. The main language I'm trying to keep as documented as possible. Unfortunately, like I mentioned, DaScript is huge. It has a lot of aspects. It's not a tiny scripting language. It's ginormous scripting language. Like a Swiss Army knife of scripting languages, it has ginormous possibilities. It's also built on some restrictions. So let me start going through the questions, since one of them covers one of the restrictions.
Yeah, one thing to mention here, guys, if you have questions, feel free to ask them right now in the stream. And moreover, if you don't understand the English, or like, for example, if you only understand Russian language, then please ask your question in Russian, and then we will answer in Russian, and then we will reply the same answer in English as well. All right, let's continue.
Okay, so the question we've received in one of the forms was, one second, how to implement cyclical linking of multiple modules. Basically, if there are two different modules with two different classes and they are supposed to refer to each other with a pointer or otherwise. How to approach that subject. So let me start with the short version. And the short answer is you don't. Language specifically prohibits any sort of forward declarations. I'll go over the rationale in a minute. So basically, if you have multiple interconnected data structures, you put the declarations in the same module. You don't need to forward declare them within the module. They're visible throughout. They will be visible with the inherited modules. And if you need to separate implementation into multiple different, let's call it containers, and you're making models for that purposes and those purposes only, that's absolutely fine, as long as your data declarations explicitly exist within the single module to keep things which are supposed to work together. Now, there are two more things in that question which I would really like to cover. First and foremost, the question mentions classes. And yes, classes are the first-class citizen in Descript, meaning there is a fairly robust class system. However, it is really not designed to massively support object-oriented paradigm. There are no class-level generics, there are no generic class methods, and the overhead of creating a class is explicit, meaning there will be a constructor, a finalizer, and for each method, there will be a member variable in the class, which is a function pointer to that method. The upside of that is that you can modify that particular function pointer in the instance of the class live as you see fit. The downside is you have a pointer per method. Your initialization is not trivial, and last but not least, your LSP will be broken unless your classes are on the heap. Hence, creating the class on this local stack requires unsafe. To make long story short, unless you have specifically using it for one of the two scenarios, one being creating interfaces with abstract methods which will later be overwritten, or second, you actually have an inheritance tree and your code actually fits object-oriented paradigm, I highly recommend to not use classes and use structures. Structures carry zero overhead and are syntactically equivalent with a pipe operator. Speaking of which, love the pipe operator. Use the pipe operator. I know it's a fairly uncommon concept for anything other than functional languages, but it's there for you. It makes your code readable. A variable piping into a method is very similar to a method call.
Is it just a syntactic sugar, or will it have, does it have any other benefits?
It's actually just a syntactic sugar. There is no performance overhead, and it makes code a lot more readable because if you pipe functions in a row, they will be executed in the order they are piped. But as far as object-oriented paradigm is concerned, if you're not using inheritance, you replace your arrow with a pipe and code stays more or less the same, minus the performance overhead. So if all you're doing is putting methods in the classes for the purposes of keeping your data next to your code, that's what modules are for. You have your class definition as a structure. You put your functions in the module, and type inheritance will actually solve those things for you. Now, let me share screen for a second.
Yeah, and I think we could rephrase that question to, let's say, I I'm a developer who came from a C++ side, and like I'm obsessed with forward declaration and header files. Could you please show me the transition that I need to do in order to avoid questioning stuff like that, like to have two modules that kind of uses each other? So I would like to do like a paradigm shift.
So the thing to address it would be like this. That's my structure A. Sorry. And it has a pointer to B. That's my structure B. And it has a pointer to an A. So I don't need this forward declaration here. I'm referring to a structure, type inheritance will resolve it. I can then create an instance of that structure. And initialize it. Set my pointer to say a null pointer. Can be happy there. Speaking of which, the very first thing you do when you start writing the script code is you enable logging. The script is actually a code generating engine, not a language. You better think of it as of Lisp of some sort. So what's on your screen is not exactly what actually happens. So the first thing is you enable log, and every time you run, you see what exactly is going on. For example, my print construction also involves a string builder. String builder is here explicitly. Print function takes a current context, things of that sort. That helps answering the question, what exactly do classes do? Let's change those two to classes. First and foremost, you can no longer make a local class. It has to be on the heap, right? Second, we can see explicitly the overhead of the class. Here's an RTTI information of the class. Here's your finalizer. And if we had to add a method, we can see that now the class holds a pointer to a function. And when the class is constructed, the pointer to that function also gets initialized. A finalizer gets initialized, the pointer to a function gets initialized, a finalizer is generated, a class method is generated. There is a finalizer for the regular type, as well as a finalizer to a pointer. Similarly, there is a finalizer for the class A, etc., 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 etc. If we go back to structures, right? We're suddenly back to nothing. And if we need to call the method, we use the pipe, meaning Let's make it on the stack. We use the pipe and then it's like this. There we go. And it gets translated to your normal function call. So if you had multiple header files, you create a module. Good example. A module. We move our definitions there. We require that module. Let's copy the incantation fully. And here we go. So if those two guys were in different headers, we put them together. If we need multiple functions in different files, we'll make a model where we require that some module. We can require it as a public, meaning it will make the definitions in some model visible, and so on and so forth. Okay, let's check if we got any questions so far. Okay.
Can you elaborate a little bit more about, you mentioned that you can put implementation into different DAS files. Can you show?
So let's do exactly that. Here's our submodule, but we need this method in a different file. So we make other module. Other module. Right. Right. Here. So here we have implementation of one of the sections. Say this would be physics. We can make multiple of them. We can make another one, which includes all our sub-implementations. The public require will make sure the definitions are visible throughout. If you need some private function, you add them as private, visible. And that one will be local to the module. There we go. You can check if it compiles in a similar fashion. So let me talk a little bit about programming environment. For the most languages, I really don't care if you use Emacs, Vim, Notepad, FAR, Visual Studio Code, Xcode, or whatever the IDE du jour you have in Works. For DAS script, we highly recommend you use Visual Studio Code with appropriate Visual Studio Code integration. And let me explain why. For the most part, what's on the screen is only minor reflection of what is actually going on in the language with the massive amounts of code generated by macros, by the language itself when it comes to generators, classes, etc., etc., etc. It's sort of difficult to follow, and it's sort of difficult to navigate. With the integration, you can point at something and actually see where it came from, where the definition is, where the files are, etc., etc. You can navigate there. your completion works after completion, which is a huge source of documentation given the lack of other documents. There are some other like refactoring things, but the first and foremost thing is the tooltip. The tooltip shows you where the data is, what the data type is, what are the properties of the type. For example, this particular type, which is B, which is defined in some module, is local, meaning it can exist on a stack. It is plain old data. It's not a raw plain old data, meaning there is the structure actually points to another structure. It's not self-contained. It can be copied, it can be moved, it can be cloned, etc., etc., etc. You immediately know the size, the alignment, and other properties of the type. And it's not limited to types or structures or fields or anything. The completion is extensive. For example, if you point, say, to a string build, to a variable, you can see how it's constructed, what's the default values for the fields are, etc., 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 where the definitions are. And second thing I highly recommend is running with options log. And if you're developing a macro, it's running with option log infer passes. Log infer passes shows you what kind of transformations the program undergoes as it's being compiled. Like this particular program is trivial, there is hardly any transformation. I have an example here of an apply macro. And it happens to correspond to our next question, which I'll go to shortly, which is response serialization. But what I wanted to show you is, if you look at the infer passes of that particular macro, you can find that, let's say, somewhere 41 infer passes later, it expands to this massive amount of code at the bottom.
Is there any limit on how many passes the compiler can do?
Yes, as a loop detection, compiler will stop at by default at 50 passes. However, there is an option to increase the number of passes. Okay, we have a question there. If there is a class without a question mark, it would not assign what wouldn't assign. Okay.
Yeah,
let's go over the question marks.
To nullables, yeah.
Yeah. It's my structure. One integer field. It's wonderful. It's awesome. Yeah. So what I wrote here is I created a structure on a stack. A local variable on a stack, which holds the data of that structure. I can pass it somewhere by reference. What this means is as you can see, the value being modified. So every time you pass a structure, it's passed by reference. It's similar to C++ reference, right? Now, we can also have a pointer to that structure. right? The question mark here indicates a pointer. It's very much similar to C++ pointer, so you can think of it as a nullable. You can new them, you can delete them, right? Obviously, deletion is unsafe operation, but other than that, yeah, you can new them and delete them just like any other C++ pointers or script pointers. And it can be null, meaning speaking of which, since we're covering the delete, here's my unsafe delete operation. This is what it expands to. It generates a finalizer for a pointer type. A finalizer for a pointer type checks if the pointer is null or not, and then causes a finalizer of the dereference of the type. Meaning, if we type something along the lines of this is same as C++ dereference operation. So yeah, the finalizer is generated. It calls a native delete afterwards, which is remove it from the heap. It also sets the pointer to null, meaning after this line, the variable b will be equal to null. And then, of course, there is a finalizer of a structure itself. Notice how it will be mem0'd as well. What this also means, I can do a delete on a non-pointer. On non-pointer, delete is perfectly safe. It generates the finalizer of a reference type, uses the same machinery, and so on and so forth. What this all ties down to is the script has no uninitialized data, meaning everything will be initialized to 0 unless you specify it. Here we go. What supposedly is an initialized variable is explicitly set to 0. And deletes will go back to that state, meaning if you call delete on something, it will be fully equivalent to having it as as if you just created it. Okay, let's see. Do we have more questions? So, as far as assignments go, this is something very interesting to cover. There is exactly 3 types of assignment in the script. First one is copy. Here I'm copying. This is essentially a mem copy. True, honest to God mem copy. No hidden overhead, no ifs, no buffs. A move. This is a mem copy plus mem0. Basically, A will be copied to C, and then A will be mem0'd. And then there is a clone. The clone will perform a field-by-field clone for arrays, strings, etc., etc. True, honest to God duplicate will be created on heap. If the string interning is enabled, an extra reference to a string will be created. If it's a custom type, a clone operator for the custom type will be used, etc., etc., etc. But those 3 are the main driving force behind writing robust code. Meaning, if I add an array of values, dynamic array that is, I can no longer copy it because a mem copy on an array makes no sense. Array is just a pointer to data on the heap. You copy it, you have two different pointers to the same data, makes no sense. But it can be moved. Right. Notice how the finalizer is created for an array. The finalizer is created for killing a particular field. Somewhere in there. Yeah, there we go. When we delete the type, the finalizer is created for every individual subtype, etc., etc., etc. So a copy makes no sense the moment we created an array, but mem move is perfectly safe because there is still only one instance of just about everything. And therefore, another robust option exists. Sometimes none of the two make any sense. And that's when you fall down to clone. Typically, clone goes back to mem copy when it can. But generally, this shows yet another property of structures which classes do not have. Classes cannot be moved. Classes cannot be copied. Classes can only be cloned.
Okay, I had like a quick question, but you almost answered it. The question was like, is there any possibility to override move behavior? For example, my question was related to classes because like in C++, what you usually do is if the class is not trivially copied, then you usually also override the move behavior.
Okay. In that script, you cannot override the copy or you cannot override the move, but you cannot override the clone.
Okay, I think that limits you to think about like mostly your data and like kind of forces you to use structures instead of classes and like try to not overthink the object-oriented paradigm.
With object-oriented, okay, so here's how you override the clone operator. Now, as far as the object-oriented paradigm, there is absolutely nothing wrong with object-oriented paradigm. We use it quite a bit in the script, mainly to define interfaces. If you look at how AST is exposed and all the macros, you can see that macro defines a collection of abstract functions, which when user derives from the class, they override or choose to not override, which is, by the way, perfectly legal to have an abstract method and not call it. And the paradigm itself is quite functional. It's just absolutely not all-encompassing. And it carries a significant performance overhead. We went with an ECS and basically object database approach instead of the object-oriented paradigm because on average, we were having one order of magnitude performance difference on a similar code. Like the typical example was a particle update. Let me check if I still have the test. Particles somewhere. Examples, profile, tests. Particles example. Oh yeah, that beautiful thing. So here's a class with an object, position, velocity, and an update. We have a virtual update, and then we have the same method, the same test with the structures, and then we have a similar test with external array and so on and so forth. Basically, the DSCS approach is roughly an order of magnitude faster and happens to translate in identical fashion. Your code tends to be shorter. Basically, lots of benefits, very few downsides, seem to scale quite a bit better. For example, it's very hard to imagine an object-oriented environment with several 100,000 objects. Usually things start crawling to a halt. An ECS example with about 1 million entities of several different types is quite robust. So language was originally designed to support ECS. It was actually born to support ECS. I remember original experiments with Squirrel, Lua, Logit, and a few other options. What was killing it there was the cost of interop. And this is something I'd like to mention. The script has ridiculously fast interop. The idea of calling something 100,000 times a frame, calling the script function 100,000 times a frame is not a lunacy. It's going to be somewhere between 10 and 100 times faster than doing it, say, with the Lua. But yeah, mainly an ECS approach is what makes things stick. We have a collection of good tests for it. Where were they? Tests. But the language was designed around ECS queries, around ECS macros, etc., etc. In fact, macros grew up out of C++ integration, being horrible and needed to be controlled with the code. Then eventually grew into a thing of its own, and now it's massive backbone on the language. Here's an example of an annotation macro. Notice how tooltip specifies what kind of macro that is and all that. But yeah, don't go too much into an object-oriented paradigm outside of the realm of interfaces, unless your problem, true, honest to God, fits the object-oriented paradigm and has a collection of inheritance. This is your classic, I don't know, UI. This is your animal, giraffe, and 3 bubbles example from the OP 101 book. Keep it for where there you have 5 objects and 3 of them different, things like that.
This is the worst example of OP.
Oh yeah. And the day after, throw it all away and start using ECS. You'll live happily ever after. Okay, we had some
okay, yeah, I think from that oriented perspective, that operations being built into the language and not give the ability to modify them kind of makes sense from the data-oriented programming perspective. Yeah. I think I had one more question, but yeah, let's continue. Let's move on to JSON.
Yeah, JSON. Whole bunch of people mentioned it. We have this beautiful JSON experimentation. I love it dearly. This is one of the first serious pieces of Dascript I written in Dascript. At this point, we're trying to write just about everything in Dascript. Back then, a whole bunch of stuff could not be written in Dascript. And JSON was the first proof of concept to make sure it's reasonably robust. The robustness of the generators were questioned. Turns out, yeah, they're awesome. Use them, abuse them. But yeah, this is very much an academic implementation of a JSON. This shows first attempts at good Dascript. It's not using piping sufficiently, but it is using generators, it's using variants, and implementation itself is robust enough to be used as a main implementation in Dascript plugin. I think we should link the plugin repository at some point. But the plugin source code is also available in an open source. and it does all this compilation of the script, highlighting all this other stuff. And it uses this implementation of JSON to talk to Visual Studio Code, goes through hundreds and thousands of objects every second. So it's robust enough to be practical. Now, how to use it? You can use JSON.das straight up. It has read JSON, write JSON, and it can iterate with a string builder, but there is a printer. At the very top, this is your JSON value. You can have an object, an array, and a string or a number, and a Boolean, very much up to similarly to JSON spec, and you can fill all those structures manually. I'm a big fan of manual sunrises and manual sunsets. If you're up for that, all good. If not, here goes JSON Boost. JSON Boost is beautiful. It has two main pieces of machinery. One is from JSON value, another is to JSON value. To JSON value works like this. You pass it anything and it turns the anything into JSON. From JSON value works the other way. You pass it a JSON value root and whatever the value is, and it turns it back to whatever the value is. A lot of it is implemented using generics, and it's expanded using generics. What this means is in C++, there is no function specialization, templates function specialization, but you can have a class specialization and you can specialize methods in the class. The script is completely the opposite. There's absolutely no templatization of the classes or structures or whatnot, but you have a somewhat similar to C++ machinery of function specialization. That means you can write a completely generic function. You can specialize it for a particular type. You can partially specialize it with a particular type, or you can specialize it with a contract. For example, expect any vector type. That's a contract which says that this function will be inferred, but for the variable v, only vector types are allowed. So when you write in a JV for your particular type, if you need to expand it, or if you're writing from JV for your particular type, you can limit it to a particular type explicitly or to particular family of types with the contracts.
This feels like a trait.
Yes. Speaking of which, implementation of every one of those contracts, like expect dim, expect any array, not dim, any enum, expect any vector type. Beautiful. You inherit from a trait. You have an is-compatible function which says, given types and annotations of the particular function, should we accept it or not? It actually does all the checking at runtime. It's written in the script, so it's fairly easy to write your own. If you write something which you think should belong into the standard library, please share those. I'm pretty sure I haven't even touched the surface on how many traits we need. Anyhow, so the from JSON and to JSON is the machinery. And let's look at the example of that all. There is a JSON example. This particular one reads JSONs from a bunch of files. First, it opens the file, it reads the file into, I think, a string. I'm not sure. Let me see. Oh, yeah, a string. And then it parses it. And yeah, and then you can access fields with is and s semantics. You can check what the type is, and you can accept it as a particular type. More interestingly, you can embed JSON straight up in your code with the JSON reader macro. Once again, the implementation is in JSON Boost. Reader macro, yes, there we go. This particular one collects whatever this input is, and then uses the same read JSON functionality to and then converts it to an expression. So if you look down into the JSON example, this particular variable actually gets expanded into more or less a constructor for the matching structure. So this would be noticeably faster than actually parsing it.
Can you show us the simple example on the JSON Boost usage? I mean, we saw the both functions. Can you like create a simple structure and try to parse it?
I'm a big fan of this particular one. Here's my structure, and we need to save it. Do we need any of that? We don't need this, we don't need that. There we go. Let's comment this out for now. So here's we use two JSON machinery for a structure with a nested structure. And we print what we wrote. We constructed the structure in a nested structure right here. That's the resulted JSON. What's interesting is the implementation of it. We can look into that stuff. We can replace this with that. And it's fairly interesting. So here's what happens right here. This particular example is an example of apply macro. What apply macro does is you pass there a structure, variant, a tuple, or a whole bunch of other things, which has a name value pairs, where the type of the value changes. And it invokes a name value block, essentially, for every pair, meaning if you have fields of the structure, it will call that. Would look something like this, right? So here we have a name and a value, right? And for the nested structure, basically regular print machinery is implemented. Speaking of which, apply is also a macro. You can see how it's implemented. It's an apply does. It's fairly documented, meaning it shows what it generates. In reality, you have good old trusty options log, and can go from there. So if you're doing the from JSON, you can very much do the same thing, right? Field. We can say from JSON value. All right. something like that, right? What are we missing? Okay. We need trace value, right? We need value. What's missing? That's actually very interesting. Let's see what's missing. Enum type. An example somewhere. Okay, that's a better example. Okay. Where's my from JV? Value, we need the default value. We need the default value. I completely forgot I need it. So let's say of that type, and we need why do we not want more? All right, I think we're running out of scope of the stream. I'll post a sample to that later.
Okay. So basically, you have two different options. The first option is to go bare bones and just use the JSON value
Well,
object
you can
directly.
use from JV. You can implement from JV something along those lines, right?
Yeah, or you can use JSON Boost, which basically uses JSON module and it builds
Yes.
on top of it. So you can use it to simplify your serialization and deserialization.
Yes, conversion to JSON is fully automated. Conversion from JSON is covered for all the main types but custom structures. And I think I'll add an example for custom structure just a little bit later off the screen so that I don't try to debug it right now.
Okay. So there is another question, like why math boost is excluded in DashBox. So when you actually check that, and it seems that DashBox uses an outdated version of DashScript. It still uses some specific commit hash. I don't know why, but even in that commit, the math boost is actually included in the standard library. So I'm not sure why your code doesn't work. So I expect it to be included in DashBox.
I think it's just an oversight, meaning the DashBox explicitly lists the modules which are allowed. So if we're missing the math boost, I don't know if Alexei accepts pull requests. I think he does. But the thing to do is to report the bug on the channel, on the Telegram channel, and we usually fix things promptly within like a day or two.
Yeah, and if you need it like right now, you can just grab the DashScript code and use it as your own module. I guess that might be also the solution. But yeah, it's better to report it and to like make the whole technology better. All right. I think the next question. I already covered some of it, on the previous stream, and we actually covered some parts of it during this stream as well. But the question still actual, I guess. Like, where is the place to look at if you want to write and use the DCS library?
If you want to write and use the ACS library, the best part, as far as examples go, sadly, is tests. Meaning there is a DACS folder and the test folder, and it shows how to test just about every aspect of DACS. This one's fairly covered. Some tests show things which are supposed to work, some tests show things which are supposed to fail and not compile. But yeah, under test folder, for example, this is how stages are set up. This is how to call them, etc., etc., etc. So tests are usually fairly small and quite explicit. For example, basic stage, you create an entity, you have a query, you run the update, and here's your update. And it verifies the expected result, etc., etc. So yeah, tests. At some point, we'll probably get to the point where we'll write dedicated examples and whatnot. I would honestly not hold my breath for it to happen anytime soon. If you feel like you're up to a challenge, I will gladly accept any tutorials, any documentation updates and whatnot. I will gladly work with whoever is writing it, answer whatever the questions possibly are, clarify, open examples and whatnot. But at this point, documenting things is a full-time job for, I'd say, 12 people for a couple of years. And it will keep happening sporadically. We'll try to automate as much of the documentation as we can. We'll try to make it as painless as possible to document things. For example, the built-in documentation system is going to come online pretty soon. But just don't hold your breath for things to be extreme, as well documented as, say, C#. I don't have that building of guys, which they do.
Yeah, like when I first look at DAScript documentation, like I was like, why don't you hire like a bunch of technical writers? Like I think that these guys can handle most of this documenting job pretty much well, I guess.
It's not really up to me. I'm all up for that.
Okay. I think yeah, I already sent the link to the Dean test, and like from that you can also have a look at that other tests which are in the same folder. So yeah, I think we covered most of these like the DCS related questions, and I think we actually could have more showcase during the jam, because like our participants can make some ECS code that actually works and could be a good showcase. Not sure, but at least we can see what they are up to.
Mm-hmm.
All right. I think the last question I already covered it, but I would like to hear more from your side about the network. Some of the participants, they wanted to use networking in DAScript, and it seems that there is only a server in the standard library. And I guess the reason for that was because it uses for, like, the plugin uses it.
Yes, basically the code grew organically. The plugin was using the proxy, which was using the, I think, JSON RPC. Eventually we got rid of the proxy. Now we have a library integrated, which actually has WebSockets explicitly. which you can use as is, meaning libht, I believe. Let me check. Modules. libhv. Yes, and it has sockets and WebSockets and a whole bunch of other stuff. For example, here's your HTTP client, here's your WebSocket client, here's your WebSocket server, and all this other nice and funny thing. So if somebody feels like having a raw socket telnet style client is worth the effort, it's probably about a day of work, half a day of work. The existing code is pretty straightforward, but personally I would recommend using something more robust like libhv, which we already have bindings for. But both options are fine by me. Personally, I'm not planning to expand on the current network until I personally hit the situation where I actually need a client. But I would gladly accept the PR if somebody makes one.
What I know is that on this jam, using DashBox, right now, at least it's not possible to make a network game. But let's say I want to just grab a Dash script and want to make a network game, right? So where should I start?
You enable libhv in the settings. Okay, basically use your settings JSON in VS Code, or you can use it as a different way of configuring things. You make sure that dashv disabled is false, and then you start looking at examples of libhv, which are not super extensive, but here's your client, here's your server. So technically at that point, you can make your network game already. It's probably a suboptimal protocol, but again, if you look at libhv bindings, where are they? Source, okay, here we go. That's my libhv bindings. It's pretty straightforward. If you're missing some sort of protocol which you want to hook from libhv, which has like a normal TCP, has a whole bunch of other things, expanding dashv would be fairly easy. Otherwise, just use WebSockets. They're already bound, there's already client, there's already server. It's beautiful, it works. We use it in a plugin.
Okay. I think that pretty much answers the question. Yeah, I think we've covered most of the questions that were in the forum and that the guys asked.
Please join our Telegram channel. If you have any more questions, we'll promptly answer.
Yeah,
if you need support, we'll support you. And that's the best way to contact me. I read that thing all the time.
Yeah. Okay. If there is any more questions, feel free to ask them now. I think we will cover some of them throughout this stream, and if not, then we will end this stream. And before we end, let me just do a quick summary for what we've discussed, and I will do it both in Russian and in English. First in English. So if you want to, basically, if you came from the object-oriented paradigm and from the C++ side, and you used to, let's say, header files, forward declarations and stuff like that, then the first thing that you need to do is to probably switch the paradigm and not to think of that script as a C++. And I think that's the first thing that you need to do. And when you do this, then the questions like how to implement circular dependencies will just naturally go out. I guess. And if you still want to do it like kind of C++ way, then you can put all your structures in the one module and put implementation into another modules. I guess that kind of makes sense if you try to think of it as a forward declarations, but it's better not to think about it like that, I guess. What else? For JSON, there are two modules. The first one is called JSON, and it allows you to work directly with JSON values. And it's a variant type, so you can check which type it is and work directly with it. It also has some simple parsing functions that allows you to work with. And on top of it, there is a JSON Boost module. You can use it too to simplify things and to avoid most of the boilerplate code that's related to the parsing and converting values from structures and vice versa. What else? For the ECS part, I guess go check tests for the ECS. The link will be on the stream in YouTube, Twitch, and Contacti. What else? If you have any about networking, so you can't make a networking game right now using DashBox. But if you want to just grab that script and go from that, start from that, then you can just use Dash HV module. And starting from that, you can start from a simple WebSocket client and then improve on that, I guess. What else? If you have any issues or feature requests, or if you want to participate, feel free to go to and make a pull request on the official GitHub. And yeah, I think it's better to do it like that way. And from what Boris said, they accepted it and tried to merge it as fast as they can. Yeah, and there will be another live stream with Boris. Let me check the schedule. Actually, I will double check the dates and the time. The next stream will be March 25th, 19 o'clock Moscow time or 16 o'clock UTC time. I guess, yeah, that's the summary. Do you have anything to add before I will redo the same thing in Russian?
Please add your questions and requests for the next stream on the Telegram channel or otherwise for normal channels. If you want any particular section of the script covered in more detail, I'll gladly go through the nitty-gritty.
Да, и теперь я повторю все на русском. Значит, быстро summary, что мы тут обсуждали, показывали, наговорили. Значит, так, быстренько по пунктам пройдемся. Значит, можно ли JavaScript, то есть использовать, значит, модули для и делать циклические зависимости? Ну, основная идея в том, что если вы пришли с мира C++ и ООП, то первое, что вам надо сделать, это сменить mindset, да, и сменить немножко парадигму программирования, вот, и перестать думать в терминах там хедеров, forward declaration и так далее, вот. Но и как только вы это смените, большинство таких вопросов, оно естественным образом отпадет. Но если все-таки хочется как-то так думать, то первый шаг, даже не первый шаг, а вот возможно, как это можно делать, типа forward declaration можно сделать, вот как Борис показал, что можно в один модуль, значит, все структурки скинуть, а имплементацию по разным модулям раскидать. Вот. Это типа как бы может сойти, но в итоге это все равно будет условно там один модуль, в котором все есть. Вот. Дальше, значит, как правильно общаться с JSON, тоже рассказали, показали. Есть два, значит, модуля, да, два модуля в стандартной библиотеке DAS. Вот. И там, соответственно, первое занимается парсингом JSON и дает обычную структурку, ну, обычный вариант JSON value, с которым можно работать вот прям вот напрямую и, значит, парсить туда-сюда и, в общем, гонять как вам удобно. И есть поверх этого библиотечка, называется JSON Boost. Это, значит, полезняха, которая позволяет вам избежать написания кучи однообразного кода, который это дело как раз парсит все ваши структурки туда-сюда. Там есть основные две вещи, это from JV и JV. Вот, ими можно пользоваться. Вот, если они из коробки не работают, вот, то, ну, во-первых, их можно расширить, во-вторых, можно посмотреть, чего не хватает, и там pull request сделать или просто написать еще. Вот. Есть ли документация по ECS? Смотрите сэмплы по ECS, ссылку я скинул на GitHub основной до скрипта, там есть, значит, тесты, там есть тесты для ECS, там, в принципе, они почти покрывают весь функционал, ну или даже весь. Вот. Почему, значит, Network нет клиента, только сервер? Это мы рассказали, что изначально это для плагина используется, но еще, соответственно, есть биндинги для libhv. Вот, ими тоже можно пользоваться, чтобы, например, начать вашу игрулю с веб-сокета, например. Можно сделать клиент на веб-сокете и отсюда начать. Вот, но есть ограничение, что в DASBox вы сейчас такого не сделаете, потому что, насколько я знаю, этого модуля там нету. Но если найдете, то пользуйтесь, почему бы нет. Вот, ну и в конце, да, что всегда можно контрибьютить, это очень приветствуется. Если видите, что можно что-то улучшить, исправить, дополнить, делайте pull request, пишите issue на GitHub. Вот, это очень-очень приветствуется, потому что open source разработка, вот как она есть. Ну еще будет один стрим, да, с Борисом 25 марта в 19:00 по Москве. Вот, ну или, соответственно, в 16:00 по UTC. Все, я, наверное, все сказал. I think, yeah, on that note, we will end up this stream. Do you have anything to add, Boris, before we end the stream?
Nope. Until we meet again.
Yeah, so we'll see you in March 2025. Yeah, 25. Yeah, it will be... Yeah, in the next 2 weeks. So we'll see you in the next 2 weeks, and yeah, we'll continue our discussion about DAScript and its features, and we'll try to cover most of your questions as well. All right, then, we'll see you. Bye-bye.